were discussing about the graph and tree of a network. So, this graph we have discussed, directed graph, it is a full graph. Then tree is a reduced form of this graph, in which all the nodes will be present, all the nodes will be connected, but there should not be, do not take any elements in the to form a tree, so that it forms a loop. So, this is a valid tree, because I omitted element 4. If I connect element 4, then only it will be a closed path generating, and so on. So, this is fine. Now, what is done is this: these are called twigs and the red ones are called the links. Clear? So, what are the links here? Element 4, element 5, element 4, element 5 and element 6, these are missing. So, what we will be doing is, we will be showing those links by red lines, this, and this, these are the links. So, this is the blue one is the tree, blue one is the tree, and red one is dotted red is co-tree. Tree means twigs, those elements we will call twigs associated with tree. Co-tree elements are links. How many links are there? Let me also show it here, that is, in this link this is 4, this is 5, this is 6. Now, what we plan to do is this: after I have drawn the links, we will be writing down the KVL equation of the loops which will be formed when you put one links at a time, and then write down the KVL equation there. So, this method of using co-tree, tree concepts to analyze a circuit will be basically the loop analysis method, loop analysis. You, in terms of, suppose I did not know about graph theory, I know what does it mean. I will take several different loops, write down the KVL equations and try to solve the circuit. In fact, mesh analysis is a form of loop analysis only. Okay. So, 4, 5, 6 are the links. So, there are 3 links which I will call L4, L5 and L6. Now, suppose I say that I want to write down, if L4 was in place here, then what will be the KVL equation in this loop? KVL equation in this loop. So, write KVL equations. For A matrix, we wrote KCL equation at the nodes. For in this case, I will write KVL equations thinking I am putting one link at a time. For example, 4, 2 and 1 will be a closed loop. Forget about this tree business, come here in the actual circuit. This will be one loop. Now, in this loop, the sum of the, here I am not showing it is true for all the branches. This is the direction of the current, I am not writing it is I 4, we have already seen that. Only numbers writing is sufficient to understand this. So, when I say V E 4, it is with this voltage across this element, is not. These things I will not write henceforth, it is understood. Now, in this loop, which is formed by this link L 4 and these two edges, this one, in this circuit, it will be KVL equation will be E 4, this you follow me carefully, E 4 give a positive sign when you are putting along the arrow, okay. That is the link will be 4. So, E 4 plus then minus E 2 then minus E 1 if you traverse this loop. So, give positive sign to E 4 whatever direction is there E 4, then E 4 if you have assigned positive voltage, then E 2 is in opposition. So, it will be minus E 2 minus E 1 and this must be equal to 0. KVL equation formed by link 4 and these two trees. Similarly, I will write down KVL equation where L 5 link 5 will be involved, that is this. If I put link 5, this is the loop, this is the loop, and what will be the KVL equation in this loop? Start from this, first go along the link here, that is E 5. What about E 2? This must be also plus, because it is this direction you have assigned plus. So, plus plus, then also plus E 3 is equal to 0. KVL equation is to be satisfied, and finally, in loop in third loop, which I have called L 6, that is this one. What is that loop? Now, here you be careful what I mean. This loop which will be formed by this link alone will be like this, start from a L 6, then this, that is in the loops that you are writing KVL, there should be only one link present. Why? Because while writing down this equation, KVL equation, I took only one link L 4 and other twos are the twigs. So, one link, two twigs formed loop 1. L 5 in this one link and two twigs, 2 and 3, this is the second loop. And finally, the loop which will be formed will have only one link. So, this 6 I will take, then I cannot form this loop like this. Okay, KVL will be satisfied, but I will always follow this rule. I will take one link at a time to form a loop. So, I go by this, then this which is not a link, come down here, not a link, this is also not a link, this is twig and your correct loop formation. These three loops will be independent loops, as you can see. So, KVL equation in L 6 I will write, how I am writing it? This one going in this direction, it will be E 6, that I will assign positive sign. Then E 3 will come, do not take E 5, E 3. So, minus E 3, minus E 2, because you have gone opposite to that direction of 6. Then from this to this minus E 1, and this must be equal to 0. So, this is the KVL equation in 3 well defined loops. How these loops have been formed? I have got the ideas of trees, I know the links, then I will take one link at a time, form a loop like this. That is the whole idea. If necessary, I will repeat once again, but let me proceed now. Once I get this, these 3 equations can be written in a matrix form nicely. What is that? That is, in matrix form, this equation will be written like this. There will be all the 6 voltages of the elements will may participate in this equations. So, here it will be 1, 2, 3, 4, 5 and 6. Here I will write V 1, V 2, V 3 element voltages, V 4, V 5 and V 6, and here it is loop 4. 3 loops are there. L 4 does not, L 6 does not mean I am considering 6 loops. I have just identified, named the loops in terms of the link number, that is all. So, it is one loop L 4 formed by link 4, another link 4, 5, 6. So, I will now put, so this is outside this matrix, it is for correctly writing down, correctly and quickly writing down the KVL equations. So, for example, in loop 4 it is E 4 is present. So, plus 1, minus E 2 minus E 1, minus E 2 minus E 1, other entries are 0, and this will be equal to 0, that is all. In loop, in this loop number 5, it will be 2, 3 and 5 involved. So, 2, 3 and 5, all other entries are 0. And in loop number 6, this is loop number 6, mind you. In loop number 6, it is E 6 is present. So, plus 1, minus E 3, minus E 3, minus 1 under 3, minus E 2, which is also minus 1, and minus E 1. Hopefully, I have written correctly. This is the thing, and this, all these rows has to be 0. So, the KVL equations in these 3 fundamental loops, they are called. Once you have chosen a tree, then the links you know, and involving links, one link only, write down the KVL equation in the original network, because we have identified the links. So, I will call this is the fundamental loop. This I will L 6, only one link should be present. Then I will say this is loop 5, and similarly loop 6 and so on. So, this is the equation, okay, minus 1, 0, 1, 0, 0, 0, 1, 1, 1, like that. Here also the entries are only plus 1 and minus 1. Now, this equation, this matrix is called a matrix B, and which we call it as a cut set matrix, and this is the element column voltages representing voltages across each element, and this is equal to 0. We got similar things in incidence matrix A into IE is equal to 0, KCL, and B into VB equal to 0. Where from we got it? From KVL. KVL in which loops I wrote? The loops which is formed by at least only one link, and links have been identified after drawing the tree of this graph, that is the thing. So, this is B matrix, understood. Now, after you get this KVL equations, we will try to see how the link currents will be related with element currents. The next question I asked, because it is loop analysis I will be doing essentially by drawing a tree, etcetera. At the end we will show that. But in loop analysis, what you need? You have to write down the KVL equations and you try to solve for the loop currents, is not? And if loop currents are known, then all the branch currents can be calculated, maybe sum of the loop currents, difference of the loop currents, and so on. So, next thing is how to express element currents in terms of loop currents, that will be the study. So, the question is, so these diagrams I will be once again needing. So, I will copy this diagram. It is like this. So, I copy it, go to next page and paste it. So, this diagram is very much needed. Now, only thing it was not copied is A, B, C, other things. So, this is the tree, O tree, etcetera. Now, what I am trying to do is this. Expressing this step is most important and you must understand this. Expressing element currents in terms of loop currents. Got the point? Now, where is the loop currents? Loop currents is one loop, as I told you, will be like this, involving this link, that is this link. If you put only, a loop will be formed. So, this is one loop current, this is IL4. Is not? This will be the loop current. What is the next loop current? So, in this diagram if I show, it will be like this. Let me use different color. So, this is IL4 in this loop, IL4. Where will be IL5? Only this link will be this one. So, this will be this IL5, this will be this. Now, what is this loop current formed by this link L6? It will be like this. I will use a different color. So, IL6 will go this way, this way, this way, and come back here. IL 6. This you must understand very clearly. So, loops has been, so here also if I show it is IL 5, I have assumed it to be this IL 5 and IL 6 is this one. This is IL 6. Then you can easily see how to write down the element currents in terms of loop currents. So, how do I write it down? Element currents IE 1 which one is one branch? IE 1 is the branch 1. What will be, there are two loop currents flowing here. Okay. Okay, first let me okay, I 1 in terms of I 1 direction is this way, is not. So, there are two loop currents involved in deciding this magnitude. This arrow let me put very clearly. This arrow will be dictated by the arrow of the links. So, this is how I have put it. This arrow of IL 4 was dictated by the arrow of this branch AB. You understood? Similarly, this arrow was dictated by this link. So, this is how it was put. Therefore, I 1 as you can see will be minus IL 4 minus IL 6, that is all. I 1 will be minus IL 4 minus IL 6. I E 2, where is E 2? E 2 is here, I E 2. In I E 2, if you see what will be the loop currents involved, its direction is like this. What are the loop currents that are present in this branch 2 or H 2 or element 2? It is IL 5, this is the loop current. So, IL 5, it will be plus because this way it goes. Then also IL 4 and IL 6 in the opposite direction. So, minus IL 4 minus IL 6. This will be element currents 2 in. So, this is the this thing. Then I E 3 in terms of loop current, I E 3 is this way, and here if these are the loop currents, then I E 3 in terms of that loop current will be IL 5 plus no, I am so sorry, IL 5, this is IL 5, it is a loop current IL 5, I E 3 I am writing, which is this way. So, IL 5 and then minus IL 6, this is 6, IL 6 minus IL 6, this will be, that is all. Only these two loop currents are present in this to decide the branch current here. I E 4, I E 4 means this branch currents. In this branch current, IL 6 is not involved, only IL 4 is involved, neither 6 not the other branch currents, 5 is involved, only IE4 is IL4, that is all. Then got the point, this current is only IL4, then IE5 will be equal to, that is the current in the element 5, only IL5 is involved, no other loop currents are going this way. So, this will be equal to IL5, and finally, IE6 will be equal to IL6. So, once again repeating very quickly. So, in to find out the element current in 1, this current I1, what I do is I see what are the loop currents that are crossing this, present in this branch as well. I find 2 loop currents are present, IL4 and IL6, but they are in opposite direction of IE1. So, minus IL4 minus IS6. IE2 is this current whose direction already assumed this way. Which are the loop currents that will decide IE2? All the 3 are there vertically. So, this IL5 is flowing like this, na? It will complete circular. So, here all the 3 loop currents will be there, IE2, of which IL5 will be in the same direction as of IE2. Therefore, it will be IL5 minus IL4 minus IL6. Similarly, IE3, this branch current, here only 2 loops are crossing IE3, that is IL5, this is the arrow IL5 and minus IL6, that is all. And IE4, IE5, IE6, they happens to be such that only the respective loop currents or only one loop currents are involved. So, this is the thing. Now, this can be written in the form of a matrix. What is that matrix? This matrix will be, because I want to express the element currents in terms of loop currents. So, it will be, if you write down it in terms of a matrix, it will be IE1, IE2, IE3, 4, 5 and 6, these element currents. It will be equal to a matrix, and this will be decided by the loop currents. Only 3 loop currents are there. They are IL4, IL5 and IL6. Once again telling you, IL4, IL5, IL6 does not mean that IL1 also exists. I just name them depending upon the number of that has been associated with that particular links, only 3 equations, mind you. And this thing here I will write IL4 also, IL5, IL6. This is for my own benefit, quickly and correctly I write. IE1 is minus IL4, so minus 1 here, minus IL6, minus 1 here. IL5 no contribution. IE2, IL5 is plus 1 and 4 and 6 minus 1, minus 1, minus 1, minus 1. Then IE3, L5 and L6, L5 plus 1, L6 is minus 1 and this is 0. IE4 is only IL4. IE5 only IL5 and finally, IE6 is only this one. So, let me put it in the proper perspective. So, this is the matrix. What will be the size of the matrix? The size of the matrix will be the number of elements which are present, that is number of rows is number of elements. So, E times how many loops, fundamental loops will be present, it is equal to the number of links which are present and number of links. And we have seen that number of links is equal to total number of elements minus the number of tweaks. This is the thing. So, this is, it will be like that, and this of course will be into 6. Now, I have already defined the B matrix. You see here, this was the B matrix. Okay. Is there any space for copying this B matrix? Let me copy that in the previous page, so that this is the nature of the B matrix. Copy it, go to next page and paste it. So, let me put the B matrix here. Okay. To get the idea, let me superimpose. How does it matter? Now, you see this was the B matrix got earlier. Now, look at the elements here. The first row was -1, -1, 0, 1, 0, 0. The first column is -1, -1, 0, 1, 0, 0. Second row was 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0. Third row -1, -1, -1 and then 0, 0, 1. So, this I then can write in terms of matrix. It is no new matrix. The element currents I E is nothing but B transpose into the loop currents. What is I E? I E is this column vector comprising of all the element current information. What is I L? I L is this loop current, once again a column vector. And what is B transpose? B transpose is that earlier B matrix which I wrote here, which we got from the KVL equations. Therefore, in case of loop analysis, we have got these two fundamental equations that I am rewriting here. One is B into the element voltages is equal to 0, that I got in the last page, that is the B into V is equal to 0. I am so sorry. This is one, and the second one is B transpose into the loop currents is equal to the element voltages. So, these two are the equations which we will be using if we want to solve the network by loop analysis method. Therefore, please go through these last three lecture notes carefully. Hopefully, you will understand, and then I will tell you in the next class there is another way of solving the network which is based on the cut set method, that I will discuss in the next class. Thank you.